When we look up at the night sky, we often wonder if we are alone. This question has driven humanity for centuries. We have sent probes and telescopes to scan the cosmos. We're searching for signs of life. Most of our search has focused on places like Earth. We look for planets with water, a key ingredient for life here. But what if life could exist in a completely different way? What if it could thrive in conditions we consider hostile? This is where our story begins. It takes us to a place far from home, a world shrouded in an orange haze. This world is Titan, Saturn's largest moon. It's a place that challenges everything we thought we knew about life. Titan is not just another moon, it's a world of incredible mystery and potential. In our solar system, it's the only moon with a thick atmosphere. This atmosphere is even denser than Earth's. It hides a surface that we have only just begun to explore. For a long time, we could only guess what lay beneath its thick clouds. The Cassini-Huygens mission gave us our first real glimpse. It revealed a landscape that was shockingly familiar, yet profoundly alien. It showed us rivers, lakes, and seas. But these were not filled with water. They were filled with liquid methane and ethane. This discovery changed everything. The idea of a world with a liquid cycle like Earth's is astonishing. On our planet, water evaporates from the oceans. It forms clouds, then falls as rain. This rain fills rivers and lakes, and the cycle continues. On Titan, a similar cycle exists, but with methane. Methane plays the role of water. It carves river channels into the icy ground. It pools in vast, dark seas. This makes Titan one of the most fascinating places in our solar system. It's a natural laboratory for exploring chemistries that are very different from our own. It forces us to broaden our definition of what a habitable world might look like. This strange, cold world offers a tantalizing possibility. Could life exist there? If it does, it would be unlike anything we have ever imagined. It would not be based on water. It would have to use the liquids available on its surface. It would be life based on methane. This concept stretches the boundaries of biology. It asks us to think about life in a new way. The search for life on Titan is not just about finding aliens. It's about understanding the fundamental principles of life itself. It's a journey into the unknown, a quest to see if the universe is more creative than we ever dared to dream. One of the leading ideas comes from researchers at Cornell University. They've explored in theory how life could function in Titan's frigid methane seas. They realized that the cell membranes we have on Earth just wouldn't work. The scientists proposed a theoretical structure called an azotosome. It would be made from small nitrogen-containing organic molecules, like acrylonitrile, which are known to exist in Titan's atmosphere. These azotosomes could form tiny, flexible, and stable spheres in liquid methane. Inside this azotosome bubble, the chemistry of life could begin. But what would this life eat? What would it breathe? In fact, scientists have looked at Cassini's data and found hints that something might be consuming these chemicals on Titan's surface. This is a startling discovery. Data from the Cassini mission showed a strange depletion of hydrogen, acetylene, and ethane near Titan's surface. It's almost as if something is consuming them. Now, this could be the result of some unknown geological or chemical process that we do not yet understand. But it is also consistent with the signature that this theoretical methane-based life would leave behind. It's by no means proof of life, but it is a deeply intriguing clue. It's a wisp of smoke that makes us want to search for the fire. It's a sign that the strange, cold, methane-rich world of Titan might be even more alive than we ever dared to imagine. Whether we find living creatures in Titan's methane seas or not, the search itself will have changed us. It'll have pushed the boundaries of our science, our technology, and our imagination. It'll have taught us to look at the universe not just for a reflection of ourselves, but for the endless and beautiful variety of what could be. Even with a working cell membrane and a source of energy, any life on Titan would face another enormous hurdle: the cold. The surface temperature is a steady minus 179 degrees Celsius. This is unimaginably cold. At these temperatures, all chemical reactions slow down to a crawl. The molecules themselves have very little energy, so they move sluggishly and interact infrequently. On Earth, the warmth of our planet and the amazing properties of water allow for rapid and complex chemistry. But on Titan, the pace of life would be incredibly, almost unimaginably slow. It would be life lived in the ultimate slow lane, A titanium microbe might take thousands or even tens of thousands of years to divide and reproduce just once. When we search for life on Earth, we know what to look for. We look for the chemical signatures of our own biology. But this approach presents a huge problem when we go to Titan. If titanium life is built from a completely different blueprint, using a different chemical language, our existing tools might not be able to see it at all. The challenge is to overcome this Earth-centric bias. We need to think about more general signs of life, signatures that are not tied to a specific chemistry like ours. One such sign is complexity. Life tends to build large, complex molecules from simple, abundant ones. Another universal sign of life is disequilibrium. Life is a process that fights against the natural tendency towards disorder. The most exciting mission on the horizon is NASA's Dragonfly. Scheduled to launch in the coming years, it's a revolutionary concept. Dragonfly isn't a rover, it's a nuclear-powered drone, a robotic quadcopter about the size of a small car. This design is perfectly suited for Titan. The moon's thick atmosphere and low gravity make powered flight much easier than on Earth. Dragonfly's primary goal is to search for chemical signs of life, both past and present. It'll carry a suite of instruments designed to analyze the complex organic material on the surface. It'll be looking for specific kinds of molecules like amino acids, which are the building blocks of proteins on Earth. But it will also be searching for the unknown. It'll look for complex molecules or chemical patterns that are hard to explain through non-living processes. Let us just for a moment imagine that the Dragonfly mission is a success. After years of exploring the orange sands of Titan, it analyzes a sample from a sheltered, energy-rich location. The data streams back to Earth, and in that data, scientists find something undeniable. They find complex molecules organized in a way that just can't be explained by geology. So, what would this discovery mean for us? It would be, without exaggeration, the single most important discovery in the history of science. Finding life on Titan would fundamentally change our understanding of our place in the universe. It would answer the age-old question, are we alone? With a resounding no. Because titanium life would be so different from ours, it would prove that life isn't just a one-time fluke that happened on Earth. It would show that life is a natural, maybe even common outcome of the laws of chemistry and physics. The discovery would launch a new golden age of exploration. Titan would instantly become the most important destination in the solar system. The focus of astrobiology would shift from simply searching for life to actually studying it. On a deeper, more human level, the discovery would be profound. It would connect us to the cosmos in a way we've never been connected before. Knowing that a different form of life exists, even if it's just microbial, would be a humbling and inspiring realization. It might make us look at our own world with new eyes, appreciating the incredible rarity and preciousness of our own warm, watery, fast-paced biosphere. We've journeyed to the edge of the solar system, to a world shrouded in an orange haze. We've explored its frigid surface, where seas of liquid natural gas stretch under a dim and distant sun. We've peered into its thick, nitrogen-rich atmosphere, where a constant rain of organic molecules coats the ground in the raw ingredients of biology. Titan is a world of breathtaking paradoxes. It's hauntingly familiar, with its rivers, lakes, and dunes, yet it's profoundly alien in its composition and its climate. It's a world that challenges our deepest assumptions about where life can exist and what it might look like. It forces us to confront the ultimate question that has driven our exploration of the cosmos. Could there really be life on Titan? We've seen the evidence and weighed the possibilities. We know the building blocks of life, complex organic molecules, are abundant there, raining down from the sky. We know there's a liquid, methane, that could act as a solvent, a medium for the chemistry of life to unfold. We've even seen tantalizing hints in the data from the Cassini mission, strange chemical imbalances at the surface that could be the faint whisper of a metabolism unlike our own. Scientists have provided a plausible blueprint, from the theoretical azotosome cell membrane to a metabolism that breathes hydrogen and feeds on acetylene. The recipe is there. The ingredients are present. However, we've also seen the immense challenges. The crushing cold of -179 degrees Celsius slows down all chemistry to a crawl. The energy sources are weak. a pale imitation of the brilliant sunshine that powers our own biosphere. The very environment that offers the potential for a new kind of life is one that would be instantly lethal to our own, so we are left standing at a precipice of knowledge, looking out at a vast and tantalizing mystery. We have theories, we have clues, but we don't have a definitive answer. The question hangs in the air, as thick and hazy as Titan's own atmosphere. Is Titan a dead world, a fascinating but sterile chemical laboratory, or is it a living world, harboring a second genesis, a form of life that is truly alien? Answering this question is one of the primary goals of planetary science for the 21st century. It's a question that can only be answered by going back with new tools and new eyes, to search for life in this strange and beautiful corner of our solar system. The search for life on Titan is more than just a scientific quest. It's a journey that could redefine what it means to be human and what it means to be alive.